Thanks so much. So quick recap. Simon here, Google Cloud. Chris, Neo4j. We're going to be talking to you about this topic. We're going to do it a little faster because we lost a bit of time this morning, but thank you to technical team for getting us ready to go, so appreciate that. Next slide, please. All right, super. I am going to start off with talking about some of the trends we currently have in the industry and then what are the opportunities that we can go after and why they're distinctly different. Then I'm going to talk a little bit more about digital thread itself and the way that we're defining it and different ways that you could be thinking about this as well. And then I'll be jumping into some of the big use cases that we've seen working with many people, probably such as yourselves out in the industry. And then I have an opportunity to hand it over to Chris to talk about the practical ways that we can go build this using Neo4j technology and a combination of Google Cloud. So thanks very much. First of all, I wanted to break this up into two categories because quite often we confuse what is trend with what is opportunity. So trend is something that we're doing and that we already have in the industry where there is momentum. And I kind of broke it down into these three. So the first thing that we see quite often, which I think is very relevant, is the use of artificial intelligence in the circumstances where the computer will outperform a person every single time. And so in many cases, we might see that being used in manufacturing where we have something like a quality inspection type of procedure, and simply people get fatigued and they make mistakes, and computers simply don't. All we have is the accuracy of the AI to concern ourselves with. It is a vastly, extensively growing trend that we see in the industry at the moment is the application of artificial intelligence in this space, whether it be on the computer vision side or whether it be on the data side. Everything is getting electrified as sort of a non-IT type of problem to occur. This is more sort of a compliance problem that has hit the industry. I shouldn't call it a problem. It's actually very good for the environment. But as an example, if you live in California and you own a chainsaw at the moment that is powered by two-stroke gasoline, you won't be able to buy that chainsaw in a couple of years' time because they're mandating that all small gasoline engines go to electric. So very good for the industry in general, very good for the environment, but it'll put a lot of pressure on manufacturers that have to now shift from what was core competency, probably internal combustion engine, into electric. It's an opportunity for the tech industry to help these companies on that journey. Now I'd like to focus more on what we're seeing as more opportunity for things that we should be going after. Top one on my chart is connecting everything, but connecting it with the digital thread. What we see at the moment, of course, is what you experience. Your vehicle is connected to your smartphone, and that's about all. Maybe it's connected to the OEM in a limited fashion. It's not connected with the rest of your lifestyle, and it's not connected with all of the different enterprise systems. So we have the foundation, but we don't have fulfillment. And so this will be a big opportunity for us all to go after going forward. The second thing, which is a lot more technical that we've been involved in because our game at Google Cloud is data, I think people really trust us for that, is building a manufacturing technology, a manufacturing ontology using our technology so that people can find the information and get better value out of the information they already have. And what we find is missing is the taxonomy around the information, an ontology for them that they can use in a way which would make analytics either self-service or make it more consumable by, say, apps or any other type of interface that they create. The other reason why we're so focused on this as an industry is that we also need resilience, as that many applications, especially no-code applications as an example, have a dependency on the underlying data. The minute we change the data, the application breaks. And so then what happens in manufacturing industries, we go back to what we've already done for many, many years, which is not anything like advanced technology, it's known technology. So we have to make this work in an environment that is very harsh and very judgmental in order for it to be successful. And then finally, of course, we can't have any conversation about manufacturing or really any conversation in the tech world without talking about 5G. I consider it a really good opportunity because of the data bandwidth opportunity. It's the way I think about it more than anything. So we want to increase the amount of information that we can process. Then we're going to have to work out how to do that sensibly inside of a factory. 5G will give us a very sensible answer for that, where today it's the bottleneck and reason why technology does not get deployed into manufacturing predominantly. Next slide, please. So when we're talking about digital thread, we first had to establish the fact that there will be many digital twins that sit inside of a manufacturing organization. And for some, this is counterintuitive because the idea was, in the first place, that there would be one digital twin and that's all it would be. It would be the information that reflects the real world in real time that you can then analyze and simulate and do whatever you would like to do. What we've found is that practically it was too big to execute. And also, to a degree, software companies were at fault because they could create a digital twin very successfully of, say, a manufacturing operations and put their software around that, but then they didn't really have software that would do the same for engineering or the same that would do for support or for maintenance. Some would try to grow that with, say, a PLM system or something in this category, but then there would be adoption problems because there were opposing systems or ways of doing work, and so the vision wasn't fulfilled. So instead of trying to create a single digital twin, the better methodology is to create a domain-specific digital twin, like in manufacturing or in engineering, and simply connect them with a digital thread. This is a more practical way of going about it, we feel, and also it's using that word that I like to often say, it's resilient, because you can change any of these over time and yet you can maintain, you can sustain that thread. But going back to core principles, we do need to have an ontology that's going to support this. It's not as if we can loosely couple things and expect anyone to understand what we've done. So we do have to have core principles behind it. What that digital thread looks like on my diagram, it looks like a straight line. We know it's not going to look like a straight line. What's it going to look like? Surprise, surprise, it's going to look like a graph. It's going to look like a really complicated graph. And navigating that graph visually will help you understand the context behind the information that today would be missing if you were simply to be looking at it in tabular format. So we think about three major categories of where twins will exist. We also think that stitching it together across the life cycle is something that is really critical. It is not just an enterprise function. Next slide, please. So our approach is to think about the value chain of the organization and then how data will flow through that value chain. It becomes the best description we have for it as a digital thread, is to think about the value chain. Otherwise, the thread would be so complicated that none of us would be able to relate it to anything that we actually do. And so we've mapped this out to make it look linear, even though we know it's not always, and sometimes it's circular. It's there just to represent how the information can work between different parts of the organization and your partners and your customers. We're building this on top of what we call the data cloud for manufacturers. It is Google Cloud. It is Google Cloud, which is tuned to have all the right components that manufacturers would need and none of the ones that you don't. So we're, if you like, we're sort of pre-configuring for you a cloud that is going to be specific to your industry. Then on top of that, we've built very specific solutions which we put in the category of being an accelerator. It's still Google Cloud, but we've put a little bit of extra code on top, some open source code, that helps you get there faster. Some of that code is, as an example, is giving you a predefined schema for you to create your own ontology. And we've defined that on an industry standard. So when you want to create your own manufacturing ontology, you might be halfway there. Maybe you'll be further there, that would be great. But at least you would be halfway there. And we've made it configurable in a way that you can change it to make it your own. Of course, all three categories are represented. So we're building for what occurs at the edge on a product as it operates, what occurs within the supply chain, and what occurs within your manufacturing operations. And if you like, not a roadmap, but it shows a vision of all the other areas where we would be building out capability we feel would be relevant. You can see foundationally to this is the connection with enterprise systems. Without this, we don't really have the core information we need to go build the thread. It is really critical. And so we have to become the masters of integration to get that information and bring it forward so that you can start to build the thread and start to do real work with the information. Next slide, please. So that looked wonderful, and it's very aspirational. What do most people end up asking us to do? Solve these types of problems. Very, very super practical. I'm in the product definition space, and here are some of the problems that I have. The people that did the design work are not the people that are doing it anymore. They're now new people. Those people retired, left, found a new job, did something of that nature. Now there's new people that have to pick up the pace and move forward. They don't have the full understanding and context of the people that were there first. And so we have this challenge of all these different systems that are there to author information and do the best job of it, that will define the product, and yet they end up being their own information silo. And of no fault of their own, by the way, it just works out that way. Not everything can be built on top of a single system, we know that. So what does it warrant? It warrants having a digital thread, it really does, because now you need to pull together different types of information, but in a way that people can understand it. Simply saying, look, when we were defining this product, we went and had a look at what was the approved manufacturer list to work out that we could get components, design them in that we could actually get supply of. It's okay to say that. It's better if you can actually show how to get to the information and have a record of that information. That quite often is missing. People will say, what was the AML back in 2000 when you designed that thing? No one can remember, and no one has it. So the concept behind this is you should always be able to know. There should be that sort of historical view of the information that you can access. At a minimum, it can show you current state. I always say that. Getting to all the information can sometimes be challenging, and so therefore begin with what you've got now, which is current state. Some other things that people use this information for is discoverability. Where did a particular feature or function come from? How did we design it in the first place? Who did that user journey? Who did it? What did it look like? And why? What was the sort of rationale for doing that? These are actually very tough questions for people to answer if you don't know the people that did it in the first place. If you do, you could probably go and ask them. If you can find them, if they're available, it's still a problem. And so hence this type of approach is very, very practical. Next slide, please. So what have we built to help with this problem? I mentioned before I kind of revealed these. We've got sort of 3 categories of accelerators that we've built. One for manufacturing, which has got 2 components to it, something that we call a manufacturing data engine. This helps you build out that ontology and connect your equipment and so on. A visual inspection AI, of no surprise there, so catering to what is a very big trend in the industry at the moment, and then the data connection between the two. Same with supply chain, another big critical component of the way that we work in manufacturing at the moment, whether it's on the logistics side or whether it is just simply managing core supply chain, like components for lead time availability and so on. And then finally, just being able to manage your products. And if we connect all of these, we have a digital thread. We have a sort of 3-party digital thread. At the core of this, we're working with Neo4j to help bring more context to the information than what we could bring to the table by any other means. And I think that's a really important part of what we're talking about, that we could do some of this on our own. And we have a relational database system, we have NoSQL, we have all these sort of things. But there's still quite a bit of heavy lift in order for you to go and build the digital thread. Not impossible, but certainly going to be very, very heavy lift. We began looking at graph technology as one way to visualize it, but also another way to bring together the information so that you can analyze it and do it in a way that's timely. I've worked in these enterprise systems for 30 years. They're too slow. It doesn't matter whether we were running them on IBM mainframes now or we're running them in a cloud data center. They're too slow for you to make a decision. Graph technology makes it lightning fast. If nothing else, you get the performance and you get way more, but just that by itself is going to help people in this industry with the adoption and reason for them to move forward. Next slide, please. So getting down to it before I hand over to Chris and he can show you how this really gets done, which I think is very important. Why do people ask for this in the first place? Why do they ask for a digital thread? And why do we believe that we can solve this with graph technology? So this is what they're asking for. We have top line of everything that's very opportunistic. These are the things that people are going after that I wouldn't necessarily say they've got some big burning problem, sort of like the platform is not on fire type situation. It's an opportunity for improvement. But then you have the bottom line where something is on fire, normally money. Yeah, is that someone is stealing from you. Like, you wouldn't believe this, actually. One of these on here, which I thought was very interesting, authenticity verification. So I had the pleasure of working with a manufacturer not too long ago that said they were seeing product being registered on their connected product network, that was not their own. And yet when they went to the customer and looked at it, it looks like their equipment. It's got everything on there, except that the serial number is a counterfeit serial number. And that serial number was appearing 20, 30, 40, 50 times, over and over and over. And they couldn't work out where it was coming from, why it was coming. They had absolutely no idea other than they were seeing registration. And so you could say, okay, they had their fraud detection maybe very simply, but then it got more complicated because new serial numbers appeared and they had to work out, did I issue the serial number? So that became a really big, nasty data problem for them. Where did it come from? Who sold it? What's underneath it? What's its genealogy? How is it made? Is that my semiconductor underneath it? Is someone else? Where did the software come from? What variant is it? It began to really explode. That's a really big burning problem. You're losing money. But not only that, we're talking about security and other things which may not even be present on that product. People didn't even know where it came from. And then on the other side of it, you've got things which also hurt money, like warranty. I've worked with any number of big automotive companies, and the type of money that they hold in reserve is the national GDP of some countries. It's a huge amount of money because they expect that there's going to be problems. Anything they can do to reduce that, they will do it. Now, you could say, just make a better car. You could say that. But it's a little bit immature to say that's the only problem behind it. There's way more. Because when that product gets serviced or when something occurs or changes a little bit out of it, this is the real world. You still have to have some sort of warranty reserve. But understanding the source and where they come from, it becomes really very critical. Plus, it's very open to abuse, by the way. It's very common that you can return a vehicle. It's not even a warranty problem, but maybe somebody does that anyway because they get compensated by the OEM. So some of these in the bottom line end up being sort of interrelated. On the top line, you see things which are more opportunistic, as I mentioned. I think probably a very good one up here is to look at what is design or supply or manufacturing variance. It's an opportunity where I've got the difference between one state over the other where I shouldn't or I should is sometimes really is like particularly unknown and not particularly well documented inside of the organization. And that can get down to consolidation. Like here's a really good example. You go to a manufacturing company, it's really, really well-meaning, but it's big. And if you're a supplier to that manufacturing company, sell the same part to 5 different people at a small volume 5 times over at a higher cost. There's a business plan for you, by the way, if you happen to be a supplier out there. You know why? It's better than selling to them on a group spend because you'll have to give them a massive discount to do that. So, you know what? Just exploit the fact manufacturers don't know what's going on. They have no idea from one side to the other. It's too big. And so you can exploit it. If you're an OEM, if you're a manufacturer, I need to put a stop to this immediately, 100%. I want one spend. I buy 5 million components from you. I don't want to do it 5 times by a million. I want to do it 1 time by 5 million. And I'm going to crunch you, because that's my job as a manufacturer, is to crunch my supply chain. So I'm going to do it the best way possible. You can go implement this one tomorrow and save manufacturing companies millions and millions and millions. And it's not just about crunching the supplier. That's a little bit, maybe sort of, doesn't sound so great for business. It is just about the efficiency, because then we get down to, supply chain constraints and things of this nature, which also surface. So these are the really big opportunities on the top line that we see where we feel that having more sort of graph technology is going to be helpful than currently where we are in the industry. Next slide, please. So what are we doing together? Well, we've got sort of 3 categories of solutions from Neo4j that we really appreciate because they're a direct match with what we're doing from a solution point of view. First of all, creating a manufacturing digital twin, we're there. So we consider ourselves a data provider. Is that not only have we got this sort of real-time information that's coming off of your PLCs, your machines, your HMIs and things of this nature, your SCADA system, whatever it might be, but also then we've got a method of bringing context to the information that we didn't have before, which we've considered to be absolutely critical. In a supply chain, just the visualization of the data itself is critical, especially if you're considering that some of these, the way that they're building out is telling you that there is a burning problem that you need to address, or there is a dependency in your network that you are unaware of. That becomes really very critical, as it does for the way that a particular product operates. And this could get down to things which affect your warranty or something nasty like a recall or something of this nature. It may also even show you things like people aren't using a particular feature versus one over the other, and so therefore don't put as much effort into that feature versus something else. And so these are all really good practical things that manufacturing companies can be working with. Now the question is how? Always how. So this is all good, I understand. I'm very much a how guy. When I've spent years in these conferences sitting where you are, and I'd always be thinking, one, can the guy stop talking? And two, can you start showing? And so I said to Chris, you have to help me out and do the showing part. So I'm going to ask him now to come up and say a few words about how we're doing this together and what would be perhaps practical for you, and hopefully something that you can take away from this session today. So I guess next slide, or next... and hand over to Chris very much.
Okay, you can hear me?
Yeah.
Okay, I'm a little stiff from yesterday, so give me a second here. All right, so what do we got here? We got I have 8 minutes? Or can we push an extra 5, or do I just have 8 minutes? Go, Chris, go, slide. Okay, I just want to say, I'm going to try to speed it up. I don't want to, impact whoever's coming after us, because actually, Simon, he was absolutely brilliant. So look, no, this is not rocket science. What's really hard about this, of course, aside from modeling, being good at graph, understanding graph, and knowing how to use Neo4j, which is critical. You can always talk to me about that. Well, the hardest part in any organization is getting all of this infrastructure, getting all of these things connected. And when I did it before, and I've been doing it for 7 years, I didn't have Google on my side, okay? I had to go into a large manufacturing firm and try to go to each organization and talk to the person who's managing the SAP system and the QA system, and go and try to figure out with their tech how to get all this done. It's not the same way anymore. Okay? So some of the huge hurdles that make this thing, viable in years has been shortened to light speed because of the folks at Google, okay? All right, so the first thing I want to do is talk about the base model, okay? What we're trying to do here, and I've even made sure that we standardize this glossary. I talked to some of my OEM partners who do this, they go around and do it, and I said, we're gonna have a name for this, okay? Let's just give a name to the industry because there's just too much stuff floating around. And it's called a context graph, okay? I have numerous slides, you can come see me at the booth. Since I gotta do this really fast, you can go to the booth and I can take all day. Cool? Okay, so it's not a master graph. Master graphs are when you have incomplete, untrusted sources of information that you are going to piece together to form some entity that you otherwise could not realize in the source systems. You're a health insurance company, you have capitation, adjudication, and some other systems. They have names of doctors and stuff, but there's no real doctor. You're going to need a master graph. That's not it. Okay? It's not like an ID management. You're not trying to triangulate things or create things. What you're trying to do is do a context graph because all your sources are trusted. And normally what you have, like some of the manufacturing firms I've been to, you know what you do? You have to go find this very special person who's an analyst that knows how to log into every system, knows all the UIs, knows the people who deal with them, and I just walked around with them. Well, I'm not kidding you. Go to different buildings. Sometimes I go to different states with them. Meet them at the airport, okay? And this is a person. That information should be captured electronically next. All right, what is the context graph? Okay, unlike master data, all the sources are trusted, okay? They're not incomplete. They have all the information they need. It's just that when you go from one system, say an engineering design system that has an engineering BOM as designed, right? You need to go over to the ERP system where it has an MBOM because you need to connect these things, okay? And let me tell you what, too, if you think you can go into the EBOM folks, do all your graph design because they know everything, wait till you talk to the folks that are on the manufacturing floor. They'll tell you they're totally wrong or this is totally wrong, they don't know what they're doing because they have to enter this stuff. And the data managers on some sides are like, I totally know what they're doing here. And no, they don't because there's all kinds of ingenuity that happens on the manufacturing floor when they enter data, okay? So what we have is key data. There will be key data, and that is data that allows us to traverse, okay, like a digital twin from one system, something that is an ontology based on engineering, manufacturing, procurement, and allow us to not lose context okay? So we can go from this system engineering, and we're talking about a power unit on a satellite, and when I go over to the ERP, it's the same thing, exact same thing, okay? I don't have to go talk to somebody, are these the same? They look the same. That should be done in the system. And that's what this is, okay? Next. You'll be able to read these slides. Okay, at the center of these things, and here, we have to have this key data. So for many of the solutions I've built, the key data is a part number. There's part numbers everywhere. They're just ubiquitous. You go from this system that deals with the part number to this system that deals with part number to this system, whether it's QA, cost, procurement, receipts, engineering, CADs, they all deal with part numbers. And what you do is, and we could talk about this at the booth, we don't have time here, but it's an actual graph community model, okay? Now, M-bombs and E-bombs and those things, that's not the center, those are snapshots. A particular top-level assembly I've seen with my own eyes with 42 revisions for one single top-level assembly, very simple too, okay? So you have these part communities. And the big deal about these part communities is something that people don't understand, is that when you start to really think about understanding processes, looking for causes of variance, finding problems, influence, right? An engineer, a bad design, a particular vendor, their influence is magnified as it goes through a community, because in a community model, you have nodes that have high influence because their centrality is high. We're going to talk about that, right? It's naturally going to happen because communities are connected trees, right? And some of those nodes in that community have tons of ancestors. Some don't, okay? So those at the center are highly influential. And when you have massive things like an entire satellite or a giant dozer, you can't like visualize what part is going to be the most influential. And that influence just traverses everywhere, right? Goes back to engineering, to cost, overruns, defects. Okay, next. So at the center of numerous manufacturing solutions that I've provided, and that's why it's called discrete manufacturing, we have what's called a part community, right? And just think about it as exploded. Like my dad's he had these big things, and he had an old VW, and he always had a book that showed everything exploded. Because old VWs, you work on yourself, right? So that's what I thought of when I thought of this. And it's really kind of no different, except for this one, you'd have to draw all the lines in there, right? Sort of. Next. So here it is. It just starts about this simple. And this is not that hard to get. You're going to get some of it from engineering. You're going to get some of it from manufacturing, because they have an M-bomb versus an E-bomb. You're going to get batch trees. All of these are going to build, okay, organically your part community, which is going to be your key data that you're going to use in this model, in this context graph. And remember, you can come by and I'll show you my entire thing on how to do that. Okay? Next. Remember, the flow of influence. So we have here an engineer, and it could be an influential part. I didn't show you where it is in some giant part community, but it has high degree. And from there, we can see all of the things that it affects. And remember, there's expansion. You guys were just in my class doing some training. You see how expansion works? The number of rows that you get in a query as you go through nodes with high influence. It's a problem with our query that we have to tune. What you're talking about, that query represents actual dynamic impact on a business, okay? It's meaningful to folks in business. Next. Okay, so what I wanted to do, based on what Simon did, we talked about this thing where he's like, hey, you have these folks that come into a business, and I think this was true for like the Ford Taurus. Everybody like built a Ford Taurus, they left, they wanted to reproduce all the awesomeness of the Ford Taurus. Lord knows that has not been reproduced. It was even in RoboCop. And I was like, that's a cool car. This isn't a Taurus, dude. Yeah, all right. It was a cool Taurus though. Okay, so here we have a case where let's say we have, imagine these aren't really nodes in this. This is supposed to be All of them are subgraphs. Cool? This is going to be a big old tree. This is a tree. Okay. So we have like some EBOM versions. They go through the part community, and they have like similar top-level assembly numbers and versions, and it's associated with a whole bunch, and this is all just churn trying to get it right. You give a design, it goes into manufacturing. Manufacturing's like, we tried, they rejected it, you know, these screws don't work, they're too long, whatever. And then there's a bunch of back and forth, okay? And in this case, as they were doing their job, it looks to me like we can look at this process and say, I know what happened. Everything seemed cool. The first version of the M-bomb went out, a batch was sent, and immediately there was a recall, okay? So all that data is in there, but you know it's in all different systems. The only people who know this normally are these analysts, who are like these like risk analysts. It's not like you can go to a database and search this out, unless, right? So let's say that you're new, you're gonna work on a similar part, the person before you is long gone, and you're gonna build that same component. You know, with a satellite, it's an artisan, it's artisan, okay? They don't put satellites on a it isn't like pencils, okay? It's easy, and people leave all the time. So these satellites, they end up, you know, doing the same thing again, right? But they didn't have this. Well, now they do. Next slide. Now, they submit the new EBOM. It's connected directly to the part community. And before they can hit, you know, submit, they can traverse this thread all the way to a recall and a quality defect instantaneously. Didn't have to like talk to the people prior. This is what should happen because you don't know what you don't know. What do they got to have to do? The risk analyst hanging over your shoulder, can I look at your EBOM? It's impossible, right? With doing this is going to be real time. You can imagine how much that saves somebody, especially if it's something that's critical like a satellite. Like a recall could be like falling out of the sky. That would be a drag. Okay. At least I think it would be a drag. It sounds like a drag. Okay, next. Whew. Okay. And another one. This is a big one. The first time I implemented this at this company that makes satellites, I guess you figured that out, we started to be able to do centrality. That means we started to be able to understand things that were influential. Okay? Centrality, all I have to do is, from this huge ontology, you have to build the ontology. Okay? That has to be done. You're going to have to roll up your sleeves and build it. A lot of the heavy lifting is being done by Google. Okay? Now, you can focus on the model. This is very, very doable. Part model, was that really difficult? No, it wasn't. Getting the data in is difficult. So now what you're going to do is do some analysis. You extract bipartite graphs from an otherwise more sophisticated ontology, and you can do things like this. Oh, look at this. This part is influential, isn't it? It's in like a gajillion M-bombs. The most influential part number on a satellite is glue. Who knew? Did you know? Anybody? You wouldn't guess that, right? And every time you look up at a satellite, just think, that thing's glued together. Chewing gum and stuff, that's crazy. Also, you have this, where you can look at a part that has been causing you a ton of problems. This part has just been killing us, and why do we have it? And when you have a lot of history, you have a very sophisticated system, it takes some guy with a whole bunch of like spreadsheets, because I've seen it myself, and I've hung out with the dude. He's a good guy, okay? This should be done automatically because the craft can do it automatically. Next. And like this is even better. They're like, whoa, that part, skip the part. I don't care about the part. Was it machined? Find him. Was it a vendor? Let's call him, right? Now, I was there. I remember doing these queries and watching everybody's faces. Ooh, as they do this centrality. So next one. Remember that too. There's good and there's bad, right? So the good is you can find like everybody who's really contributing to the top line, excellent parts, great structure for M-bombs, but on the flip side, like they did right away, is like human nature. Hey, let's go find the engineer that's related to the most defects. Yeah, that shows right up, okay? So there's a dark side to centrality. Okay? And it's just a simple measure. Once you get a graph, how hard is centrality, right? It's really not hard at all. Try to do it with sets. Yeah, think about that. Okay? Next. So one of the things that everybody would talk to me about after they knew I did manufacturing, and they come up with these buzzwords, and I'm just doing graph. They're like, I got process mining. You do process mining? And I have to go look it up. All right, whatever, what's process mining? Well, we do natural process mining. Of course we do, because we can follow a thread. That means that we're actually maintaining context. And based on a context, a certain operation, a certain result, we flow through all kinds of things. And you know what it turns? Sometimes it's like, what is our thread? It's a process. And what does that process mean? And we can see all the number of times it's done it, the variance, the complexity, right? So here we have a process. Maybe that is longer than you would have thought. The visualization alone, but we got all kinds of measures too. We can measure the length. We can measure the number of unique permutations, can't we? Because there's a lot of paths in this. This all leads to complexity. And these are just metrics that we can use. We could go through the entire graph and compare these. We could do a top 10 complex processes in the entire organization that lead from design to batch. I haven't seen that yet, and why not? I don't understand. Next. Also, this is a case where you can see that maybe you're dealing with something that's very similar, and you can say, like, why is it that we have a process, they both lead to things that are basically identical, and the complexity measurement for one endpoint is a fraction of the other. Now that's a way to go back and look and say, can we learn anything? Right? How else do you just pick? And they do this at this organization. They get awards for like trying to come up with ideas to fix the business. And they have no feedback. They just throw things over the wall and see if they can get an accolade. Well, now they have a chance. Next. All right. Not bad, huh? Okay. So, things to remember. You can do this stepwise. This is not a build it and they will come. Start with simple questions. Hey, can you tell us what part in the part community is causing most engineering time? Let's just do that. That's two sources, right? Architecture, remember, whatever you build is going to have to support ad hoc queries. That means your graph. It's going to have to, right? It's not going to just be an API because they're going to have to analyze it. Remember that you're going to have a real-time loading. It's going to be real time in the end. They got to ask real time questions. They got to have an EBOM. They want to know that this is going to be good right away. They want to say validate. That means everything has to be up to date. Cool? So it is not going to be batch. You probably do it at first, but it's always going to end up being real time. That's why Google's going to help. Embrace schemaless because ontologies are there to evolve. Period. End of story. Your business is dynamic. The model you have to start with will not be the model you end with. The model, all models are wrong, some are useful. Your first model will not be that useful. The last one you work on, and before you move on, I guess, will be far more useful. And schemaless helps us do it. And finally, just a real quick understanding that, and I'm sure there's some annotation and stuff like that, but you should be assuming that you're like folks at Google are creating digital twins and you're connecting them, and that is cache. That's why it's real time, because it represents the current version of truth. Whatever that is, it's got to be the current version of truth. And they could ask you to do things in history, but it's largely cache, and why is that? Because it's information that's coming from other sources, and it's dynamic, okay? Don't think that ontologies are durable, all right? Whew, that was my fastest presentation ever. I'm only 10 minutes over, but I appreciate it. Simon was awesome. Everybody, Simon. Yeah.